Okay, great. So we're going to go ahead and get started. I'm Dr. Thomas Madura. I am an assistant professor in the Department of Physics and Astronomy at San Jose State University, which is smack dab in the middle of Silicon Valley. And today, my collaborator, Dr. Carol Christian, who's the Hubble Space Telescope Outreach Project scientist, we're going to talk about a program that we've put together. It uses a combination of 3D printing and a bunch of other things to kind of try and motivate students with visual impairments, blindness and visual impairments, to become interested not only in astronomy, but just science and STEM careers in general. And we only have a few 3D print models up here, but actually after this talk, we're going to be in the exhibit room and we're going to have a table filled with all kinds of different tactile astronomy models that you can come and experience yourself. But basically, let's go ahead and get started. So the problem, this is something that was kind of summarized a little bit by Noreen just a few minutes ago, which is nearly everything we know about the universe comes from either studying light or running computer simulations, with the exception of very recently in the past few years. Now we have gravitational waves, but otherwise, pretty much everything else, even everything in the solar system, we only have light. We can't send probes to different places outside of the solar system, so we basically have to rely on light in the interpretation of it and then doing some fancy computer simulations. Also, for a while, most astronomy data has just consisted of two-dimensional images or pictures and data, maybe light curves, maybe some 2D spectra. Again, only recently have we started going into what's called like multi-dimensional and time domain astronomy. But even though the universe, as far as we know, is at least four-dimensional, although there is a new paper now that says that the universe may actually be intrinsically two-dimensional and our reality is some weird projection out of it. So it's interesting if you want to read that. It's actually really interesting because they speculate that life itself may not be limited to 3 dimensions. And this was something that was recently reviewed by MIT, so that's pretty interesting that life may exist in 2 dimensions. But anyway, so the questions we want to ask is, okay, well, can we do better than pretty pictures? And can we teach the wonders of the universe to those with visual impairments? Obviously, the answer to both of these questions is yes, otherwise we wouldn't be here. And Noreen has actually already shown us a number of different ways that we can do this. So one of the things that we've come up with is this thing called the STEM Career Exploration Week. This is something that we've done with in a couple of different states. The first one was in the state of South Carolina. We've done 2 of them so far in South Carolina. We've done a couple in Michigan, and we'll be doing another one in August. Basically, the purpose was to use 3D printer technology to help students with visual impairments. Usually, the targeted range that we had was high school range, age 15 to 18. Explore STEM careers with just kind of using astronomy because that's what we're experts in. Some data sonification techniques. But in addition to this, we also take them on field trips. And we take them, I'll show you a couple of places that we've taken them to teach them about possible career paths in STEM. But also, we think it's really important for them to have STEM role models. So role models, professional scientists and researchers who are blind or visually impaired, that they can meet and learn that they can go and be successful. Okay, so the first one we did was at this Ellen Beach Mack Rehabilitation Center for Employment in Columbia, South Carolina. What they did is they were able to get some funding and we set up a 3D printing lab. So the lab has 6 3D printers, a large wall-mounted touchscreen monitor. Everything there has accessible design software, so things like JAWS, screen reading software, all that type of stuff. The gentleman who runs this lab is actually blind. He actually runs all of the 3D printers and all of the software and does a lot of the 3D printing himself, and he's almost completely blind. His name is Derek Strick, and I'll talk a little bit more about him later. So our team of scientists, so it's myself, Carol Christian, another gentleman by the name of Dr. David Hurd. He's a professor of geosciences at Edinburgh University of Pennsylvania. Him and a collaborator of hers named Kasanya Runyon, who's actually from South Carolina. They have authored basically all of the Braille books that that NASA has available. So they have done Braille books for studying the surface of the moon, the surface of Mars. They've done one on eclipses. They've done one on small bodies in the solar system and Kuiper Belt objects and such. He is also fantastic. He comes out and helps as much as well. And then a couple of our role models. So one was mentioned earlier in Noreen's talk, who was Dr. Wanda Diaz-Merced, she is a professional researcher. Her PhD actually, I think, is in computer science, but she does data science and data analysis where she does sonification. So she actually takes astronomical data, and converts it into auditory signals, into sound, basically, to do processing. And then how I got into this was actually this gentleman named Mr. Kenneth Silberman. He works in the Office of Education at NASA Goddard Space Flight Center, and so my background originally is not in accessibility and outreach. I was working at NASA as a postdoc, and so my background is actually in theoretical and computational astrophysics. But I was working on a project at NASA where we were trying to come up with innovative ways to visualize astronomical data for multidimensional objects. And one of the things that we did was 3D print this thing, which I'll show you. So this is the world's first 3D printed nebula. It's based on actual astronomical data. It's the Eta Carina Homunculus Nebula, and it's based on infrared observations from the Very Large Telescope Interferometer in Chile. And we did a 3D print of it. I'll be happy to talk more about it if you want to come to the exhibition booth and feel it and learn all of its intricate features. I'd be more than happy to tell you about it. But I met Ken and was showing it off to him, and he goes, you know what, this would be an awesome, excellent way to try and get students with blindness or visual impairments interested in astronomy. So the thing I didn't mention is Ken is, he's an engineer and a registered patent attorney, and he's completely blind. And like I said, he works in the Office of Education at NASA Goddard, and he helps recruit for NASA's internship program. So that's another thing, is if you are or know any students with visual impairments or other disabilities who might be interested in trying to do an internship at NASA, he would be the person to get into contact with. Okay, so the students, we typically have 10 to 15 students, high school age, ages 15 to 18. They represent all ages of the state. They're identified by their transition vocational rehabilitation counselor as having aptitudes and interests in science. They actually come for the whole week. They stay in the dormitory on the campus. We see them every single day. They do kind of like basically a half day of interactive lessons, and then they do field trips to museums. They do some social activities. They play in the 3D printing lab. Basically all these different things. We also do a little bit of pre and post evaluation. One of the images that we have up here is, so I mentioned we take them on these field trips to different places. One of them is in South Carolina. They have, Boeing has a giant factory that they opened not too long ago. It's the factory where they build the 787 Dreamliner aircraft, commercial aircraft. And we were able to take the students there and give them a tour and have them learn about different types of STEM careers. Now, amazingly, when we went there, we didn't plan this, but when we went there and they gave us the tour, they told us two things that were interesting. One was they have a person working at Boeing who is blind, and he does coding and data analysis and computer programming. The other thing was they also have a team there that does 3D printing for 3D printing different prototyping parts for the aircraft. Playing with different materials, all of that type of thing. So it was like the perfect mesh between our program and what was going on. So this is just a table to give a few ideas about the types of projects that we're doing. I'm not going to go through all of these, but basically, for those of you who can't see, it's a table that lists all of the types of activities we do during the week. So we start with constellations, both in 2D and 3D. We work through the solar system, getting a feel for the moon and Mars. Then we talk about the structure of the sun. Then we do stars and stellar life cycles. Those of you who are astronomers, I have a tactile Hertzsprung-Russell diagram that teaches the evolution of stars. We do star clusters. Carol's done star clusters and galaxies, and then we also do nebulae, and talk about 3D printing and all that type of stuff. So they get to do, and these activities range between half an hour up to maybe an hour and a half. This is just to give you an idea of one of the examples. This is so on the screen I have an optical image from the Hubble Space Telescope of the nebula, and then next to it is images of the 3D print model showing the different features that were identified. And again, you should come up and feel it for yourself. These are on the screen now are just some sample images from all the different activities that we've done. Just kind of snapshots showing the students interacting with the different models. Another one that we did that was really cool is since David Hurd does geology, one of the things we thought would be fun to teach the students how to use the 3D printers is, so if you're unaware, they have these laser scanners where you can take a small object and you essentially set it on something that looks almost like a small record player, and it spins really, really slowly. And there are lasers that will scan the object and create a 3D model of the object that you scan and then store it in the computer, and then you can 3D print it. So it's basically like a 3D photocopier. Yeah. So what David did is he brought some meteorite samples, and we had the students take the meteorites and put them on the turntable and laser scan and make copies of the meteorites, and then they could 3D print the meteorites and take them home with them, right? To teach them a little bit about the technology, and then also kind of as a nice little interactive thing about teaching them about geology. So then, like I said, we have our mentors, our role models come in, and they talk to the students about their experiences. You know, what was it like for them to try and go to, for them to, try and pursue a career in science or engineering? What was their experience like going to college? Giving them kind of tips and advice, or these are the things maybe you should try and do. Maybe these are the things that you should try to avoid. Derek kind of gave them a little lesson on the 3D printing software. And then, like I said, we just kind of summarized the different possible career paths that they do. So this was such a success in South Carolina. We met up with a couple of other people from the state of Michigan. Yeah, I'll do it right. And basically, this is just showing that we've also been doing this. We're starting to try and branch out to other states. One of the things that we did over a weekend last September, which as far as I know is the only time that we've ever done this, is we did a thing where, so 3D printers, I don't know how many of you are aware that the price of 3D printers has dropped drastically. We bought a bunch of 3D printing kits from China for a little under $200 each. So you can now buy your own desktop 3D printer for under $200. And we actually had, and if you think you can't put it together, here's a challenge for you. We had about a dozen students with blindness and visual impairments assemble the 3D printers themselves and get them all set up and working. And we had to kind of outline it. We had to figure out how do we set this up so that they can actually do it. And they did need some assistance, and it took about twice as long as we had originally anticipated, but it worked. And then we actually let them take the 3D printers home so that they could try and learn how to work with them. But these are the types of activities that we can do. So now I'm just going to hand it off to Carol, and she's going to go ahead and tell you about her program with Hubble and the data that they've been working with. So we're going to transition here real quick. There you go.
Okay, thank you. This part is I wanted to give a little vignette into how we do some of this printing and how we transform scientific data into the models that we are going to use in the camp. I wanted to start out with the 3D astronomy team, which was started about 5 years ago. I was the project investigator, and Antonella known as the science PI for the original tiny bit of money that we had. And we had a number of programmers, but also Noreen is a collaborator, and down at the bottom, I do note, in addition to all the collaborators on the program, that we had 2 students, and Anna was one of them, and Liganth, who was a high school student, also participated in the program with us. So where we started was the slide I'm showing now is where we started, which was a program that was called You Can Touch This, Star Formation at Your Fingertips. And the idea was, as I show here, to take data from the Hubble Space Telescope and transform it into almost 3D, sort of 2.5D. So it's intensity representing the visual image, but we needed to use textures. And where would we go? Well, we went to Noreen and said, could we collaborate with you and you teach us how to do textures on the star clusters? So we started with the one star cluster, and then we had to do considerable testing. And Noreen actually designed with us the test suite, and we took both a slate of textures like a legend with us, as well as some of the swell form pages that had the same object, and then the 3D prints. And in the end, most of the people who helped us, who were blind and visually impaired, said, just give us the prints. So we stopped bringing all the materials and we just started giving the prints. But the idea is we really had to test the textures, because we don't want to go into an educational outreach situation where we have a medium that can't be used effectively. So we really needed to define carefully the textures and test them. And so we did a number of other star clusters. So these are star clusters, and I'm showing here two of the star clusters. One is the Lagoon Nebula, and the other is Westerland 2, which happens to be our 25th anniversary for Hubble Space Telescope, and you can take a look at the print. But we did print Westerland 2, and if you can, again, we'll be in the exhibit booth and you can compare the two, and you can really see that this is the cluster, and there are different textures that represent the stars, the gas, the dust, and a mixture in the 3D print. We created our own program. It's a custom program that was built by the programmers who work on Hubble Space Telescope and the James Webb Telescope, so they're very familiar with Hubble Data. And it's an interface that allows automatic processing of the scientific data, and then we can tune the textures to what we think is a better match to the visual representation. We have plans to do other wavelengths, but right now we're using the visual representation. And then here again is what I just showed you. In this slide, there is an image of Westerland 2, a double cluster with lots of gas and dust out of which it formed, and then the 3D print representation of it. And again, you can take a look at those downstairs. Then we decided to move on to galaxies. We had another project on which I'm on the science team, and we proposed to make 3D prints of, it's actually 50 galaxies. I haven't done all 50 galaxies. I sort of cherry-picked the ones that are the best. I have a couple of those models here. The image that I'm showing here now is one of the spiral galaxies, which is an open spiral. The arms are very, very open, and so it was the easiest one to start with. And so we produced a number of prints. I just wanted to comment that you will see and feel when you examine the print that I can only print with a MakerBot, which is a modestly priced printer. I can only print half of it, so I have to glue them together, and that's a story in itself. This is my favorite one, which is pink, hot pink. We are also thinking about how we can do this in more translucent and possibly light the images and have different temperatures, but we're not there yet. I will say that we had to go through this whole process again of the textures, because it turned out that as our models our representations of the scientific data became more complex, the original textures didn't work perfectly, so we had to, but we still wanted to make sure there was a translation from star clusters to the galaxies, because galaxies by and large have star clusters in them. So we wanted there to be one-to-one correspondence of our texture for stars had a reminiscent texture for star clusters in the galaxy. Gas and dust translated, but because the galaxies have a higher fidelity and intensity, we needed to alter the textures a little bit. So we had a whole bunch of people testing the textures, what they liked, what they didn't like. We made, and then we voted, and then we printed some stuff and we tested it, and thereby iterated until we came up with something that we liked. So this is, again, the example showing a slide of NGC 1566, which was the prototype start galaxy that we used first. This slide that I'm showing shows an image of a more complicated spiral galaxy, which is pretty, but it's not as open, and it's a little bit more complex to print. And so I'm showing the visual Hubble data, and then half of the print from the MakerBot interface, and then a couple of examples of when we tried. I don't know. I didn't move. Okay, unhappy. And this, again, is the interface where it became much more complicated with the spiral galaxies of delineating. We can add and subtract clusters. In some case, this particular galaxy has a lot of clusters in the upper right. And if you use the actual astronomical data, it just becomes too confusing. So there has to be a little artistry in representing the data as well. But it is all the scientific data, which is measured by the team. And then I use that to make the print. And then again, this is the MakerBot interface, ready to print half of it. These are the printers that we have in the lab that the students have used. Sometimes things go a bit awry and it makes spaghetti all over, so I'm showing actually Anna made this slide. We did have a situation where the filament goes everywhere. Anyway, in conclusion, we really thought it was important to test all the textures and take it to some day events at, for example, Maryland School of the Blind, the Youth Slams at National Federations of the Blind, and then we did all that preparatory work so that we would be prepared to participate in the Career Exploration Lab summer camps. And that's my presentation, and back to Tom.
Okay, so basically I'm just going to transition really quick here and wrap up. So we found from our surveys, we're still kind of processing through the data, and we want to gather a little bit more data before we release the models. So part of the point of what we're doing too is to actually test what we're doing with the students and get feedback from the students so that we can improve and refine our models and make sure that everything that we're doing actually translates, that we're not teaching them the wrong thing, that we're not conveying misconceptions, that they're actually understanding and learning what they're supposed to be learning. And in this process, obviously, we've been learning a huge amount. So one of the things we also did is we had a table. So the IAU had their last big general assembly in Vienna, Austria, this past August, and we had a table there. And what was amazing was not only does this translate to students, here in the U.S., but one of the things that they did while we were there was they had the local Viennese School for the Blind bring their students through, and they brought maybe about 20 or 30 students by, and you can, for those of you who can see at the bottom here, there was a young gentleman who is handling some of the 3D prints, but there was a German translator there who was so I'm standing on one side of the table explaining what the 3D print is and what it is what he's feeling, and then the German translator is standing there translating it into German and translating it to him, and then he would ask questions back to me about what it was that he was feeling, and he got it. Like, he completely understood what was going on. He was asking great questions about, why is it doing this? What is this? What's causing this? And that just gave us that was just probably one of the best experiences I've ever had with this. Was it just shows that that it works, at least so far. And then we do have a picture of Wanda going around. She's also been giving us feedback on the models, and we've been kind of talking to her about what works and what doesn't work. So some of the models are available. So we're not the only ones who are doing this. There's an international collaboration. There are a bunch of people around the world who are developing 3D models of all kinds of things. The International Astronomical Union has a website where they have some models available. Some of our models are also available on the NASA 3D Resources website. So this slide that I have up here just lists a couple of the links. So the main link to the NASA archive, and then the link also to the current IAU archive. And the goal in the future, the whole point of this eventually is to hopefully have a nice big repository where all of the 3D models are available, and you can go and you can just download them and 3D print them. Or if you don't have a 3D printer, what's nice is there are these online 3D printing companies where you can just take a model and upload it to the website, and you pick the material you want, and you pick how big you want it, and they will 3D print it to you, 3D print it for you, and then mail it to you, right? And then hopefully we're also working on having like guided activities that can go along with the models themselves, right? So you can't always have an astronomy expert there with you, especially if you're teaching high school students in the high school. So we want to have these guided activities so that the teacher can basically just follow and use the model. Or another idea we've had is to just create a website that has all the information you need on it, and then you just link that to a QR code sticker, and then you just slap the sticker on the model, and the student can literally take their smartphone, scan the sticker, it'll take them to the website, and their screen reader will read them about the model and what they're feeling. We've had all kinds of different ideas of what we could do. So the next steps, so we've been trying to get funding from the NSF to do a big national study with this. We haven't had much success with that, unfortunately. I guess they're worried about small sample sizes. We're trying to extend this to more schools around the country. We want to share, like I just said, what we learn and make. We want to make it available worldwide. One of the other things that we're really interested in is trying to make the hardware and software more accessible so that the students can do a lot of the model design and 3D printing themselves. But 3D printers and, as you can imagine, computer-aided drafting and computer-aided design software are not very accessible to those who are blind or visually impaired. So we're trying to come up with ideas for how we can do that. And I am more than open to suggestions if anyone has any ideas. The final thing is we've been invited, so there's an annual American Association of Physics Teachers conference that happens usually, I think, twice a year. There's a summer meeting and a winter meeting, but we've been asked to do a half-day workshop at the next meeting, which will be in Orlando, Florida. So if there are any of you in here who are physics teachers or know of physics teachers who want to participate in this, and they have all kinds of other workshops for other things. We're going to be doing a half-day workshop on new ways to visualize and teach astronomy, talking about methods for doing 3D printing and tactile graphics. And so this will be a hands-on workshop where, as an educator, you can learn how to actually do this yourself, right? So part of the problem is that we're only a few people. We're getting more and more around the world who are starting to do this, but we want to get as many people involved as possible so that we can have a nice, large, sustainable effort, so that we're not having to reinvent the wheel every 5 or 10 years, right? So that I think is the eventual goal. But if anyone is interested, I think this would be a great way to learn. Again, the application will be astronomy because that's what we do, but the things that we're doing in here can be applied to any STEM field. You can do it in chemistry, you can do it for biology, you can do it for architecture, you could do it for archaeology, you could do it for art history if you wanted to. All of these tools and techniques are basically universal for any field. Okay, so that's pretty much all we have to say. So if you want to reach out to us, here are our email addresses, and I thank you for coming. And then again, come down to our exhibit booth so that you can explore the models for yourselves. Thank you very much.
Would you say what the email addresses are, please?
Yes, so the first email address is my first name, Thomas, Madura at sjsu.edu. And then Carol's email address is carolc, C-A-R-O-L-C, at stsci.edu.
Thank you.
Any questions?
I was just gonna, while you're thinking of your questions, I was gonna relate when you were talking about some of the reactions. In the early testings, Noreen had encouraged us to go to our local Maryland National Federation of the Blind to test some of the textures, and we took the star clusters at that point. We hadn't done galaxies. And so we had quite the gamut of people who were blind from birth, visually impaired, the full gamut. And the age range went from 10 to 84. So the 10-year-old whose mother was a teacher came in and we started explaining about stars and star clusters. The 10-year-old gave me a lecture about star formation and gas clouds and collapse and rotation and multiple stars. So I just let him tell me about it, and then he critiqued the print. And then the 80-year-old was amazing. He had lost his vision, but he had taken astronomy in college, and he remembered it all too. And he pulled up all this information from 60 years before. So I was like, at that point, I was like, okay, I'm done. So it was a very interesting experience.
Yes, go ahead. I think you're the only one right now.
Can I ask two questions? I'm doing the 3D printing project in Japan, so I have two questions. The first one, Korea Exploration Lab. So you have 10 to 15 students for monitoring. And do you keep monitoring their career? What kind of university they enter, or how do you monitor their?
So we're trying to stay in contact with the individual agencies, and it's been a little hard because so with the one agency, it's becoming a little bit more difficult because the person who I was working with has left and gone to a completely different job. So it's making it a little different. So I'm hoping to try and reestablish contact with them. But we do try and follow some of the students. So some of them, they do go to college for engineering or other fields, other STEM fields. But I haven't, a lot of them have just started. So this program we've been doing, this is, I think, our third year doing it. So we haven't been doing it for very long. So we don't really have, now every year we try to have new groups of students. So I think total, we've had maybe 45 to 50 total students over the 3 years. Although we haven't done the third year yet. We're going to be doing it this August is the next one that we'll be doing. But yeah, so we don't have too much information on that. So for instance, I don't know if he went and then was deterred and changed majors or dropped, or whatever. So we don't have any of that information yet.
Thank you so much. It's a good information. Another question is transforming HSC data into 3D printers. So this software can convert not only HSC data for other astronomy data.
Can it do other data besides HST data?
In principle, yes. The thing is that it's the sad fact is that the two programmers work for the James Webb Space Telescope, and I don't know if you know anything about that, but we're launching in another year and a half, and so I have to beg for their time. So it's not quite a package that you can package up and send out. I would like to be able to have it so that we can do that, so other people can use it, but that means I also have to write a user manual. But it's not real difficult, but it is quirky. But yeah, in principle, it could take, it can take a number of image formats in, and then you select some parameters for the automated process, and then you look at it. If you don't like it, then you start doing some hand tuning, because sometimes, like the one galaxy, which is very messy, it's just like chaos. So the idea was to try to at least delineate. When you visually look at the galaxy, you can see the spiral arms, but the automated process is just faithfully looking at the brightnesses. So you have to do a little artistry. So, I mean, the point is to get across the astrophysics, not just do data representation. That would be an interesting thing to talk about, how you discern spiral structure, as opposed to just having a collection of numbers which represents the data. So that translation sort of needs a little assistance. But yeah, in principle, we can make it available at some point, yeah.
Thank you so much.
So over here on the left.
Yeah, along those lines, kind of to follow up, so have you thought of, because I do some visual representation in 3D printing as well, mostly in chemistry, but have you thought about it from the term of, do I want to represent the data hardcore, like this is what it is, or do you say, this is the point I'm trying to get across and go from there? So that's
It depends. It depends on what. So I've done a little bit of both. So one of the things, if you want to come down and sit at the booth, is one of the new things that I've just done was so all of the data from NASA space probes of the surfaces of the planets is available online by the USGS, U.S. Geological Survey. And so I've started taking the data and putting it into software to create tactile models of the actual surfaces of planets. And this one's not a planet, but I did Pluto because I thought it was the most interesting. We just had the New Horizons probe go by Pluto, and so I'll just show you as a tease to get you to actually come down to the booth. So this is a big section of the surface of Pluto from the actual New Horizons data. So this is the actual data from New Horizons, and it almost broke my computer because these are huge data files. It uses something like when I try to visualize this in the 3D software, it uses on the order of like 60 gigabytes of RAM just to hold the file.
Do you know, just as a real quick, do you know how many triangles that is?
So for this, I had to create the mesh myself, and to get the same level of detail, you have to have your mesh be the same resolution as the original image, and the original image is 25,000 by 12,000 pixels.
I was gonna also, in response to that, so for the Hubble data, we can do the relief printing like that, but you won't really get a sense for the object unless you put the texture in. So the texture, because we tried different textures, and it's a balance, because if you try to use the kind of resolution of the texture you want, you can't feel it. So the 3D print is coarser than you would experience if you could see it, but it does represent the astrophysics. And Hubble data is always this, how do you do the colors, da 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 da. So there's all that too, and the idea is we're trying to represent the astrophysics that was measured by the science team. And so some of it is just like our press release pictures. There is some artistry in it so that you represent the concept. If you want the data, we have a public archive and you can get the data as well. So yeah, your point, it's a balance.
I think Mike had a question.
Well, sort of comment and question. I wonder if the problem with feeding the spiral structure in all of that data has to do with the difference in how we perceive things tactily and visually, because we're really wired for pattern matching. And I know visual observing with big telescopes, you can look for 20 minutes and eventually see things you didn't see before because you put stuff together. So maybe a ridge on it or some other clue. Is that it?
Yeah, that's what. Yeah, exactly. That's what we do. So if we use it, so the science part is that the HST measurements, which are in the visual, we use the measurements as a surrogate for the mass structure. It is not equal. We say mass produces light, and we make that, but that's not true for dust, for example, because dust is dark. In the infrared, you might see it, or the radio. But for the visual images, we make this link between the emitted light and mass so that we can represent a structure. So it's a bit of a cheat, but at least represent. So we do that's the point of the paint program, is that to follow the ridge lines. Because if you just use intensity, there's a lot of undulation in it, and you wouldn't really get the sense of the spiral structure, except for the pink one that I have here, where it's obviously has spiral arms. But for the more complicated ones, you wouldn't discern the spiral structure unless we do use a texture to delineate it and distinguish it from the gas and dust. So your point is well taken.
Is that because we're using different organic software to evaluate the input from our
Yes,
versus visual?
yes, and the visual representation from Hubble is mostly visual and UV, and so it's the visual and UV light doesn't necessarily represent the mass and all of the structure. So you really need the multi-wavelength to represent the structure, and it would be great to have that analysis of the structure and then faithfully reproduce that. But we don't have that for all the galaxies, so we're just using the visual light as a surrogate.
Any other questions? So we have a few minutes. I think technically we still have like another 10 or so minutes before we have to head out. So if any of you are curious and want to come up and start exploring the models before we head downstairs to the exhibit hall, you're more than welcome. And then, I'm sure other questions will pop up as you're exploring the models. Thank you again for coming.
Thanks for coming.